Sorry, I just have to handle some little issue with my little kid. Now, I saw this question very interesting, and I really want to handle it on the live class with my viewers. The question says we should find the value of negative 1 to the power of pi. Now, what will the solution of negative 1 to the power of pi give to us? This is an Olympiad exam maths question. Now, if you are asked to solve this question, what will you do? I found out that using Euler's identity, you can truly find a solution to this question. Now, how do I go about doing this? Now, we have negative 1 to the power of the square root of pi. Now, how do we do that? Remember the Euler identity, the exponent of pi I plus 1 can be equal to 0, right? Great. Now, if I have this, I can have this exponent of the pi of I to be equal to negative 1. So that means I can displace this negative 1, or I can replace this negative 1 with the exponent of the pi of I. So if I do that, I'm going to have that expression to give me the exponent of the pi of I, right, multiplied by the square root of pi. Great. And this whole thing can still be equal to the negative 1 multiplied by the pi, the square root, the power of the square root of pi. Now that means if I can get a value of this, this can simply give me the result of this. Now what I'm going to do is to simplify this expression. And once I simplify this expression, I'll be able to get the value of this. Now if I simplify this expression, looking at the laws of indices, we're meant to multiply the exponent. So if I multiply the exponent, I'm going to have the exponent of pi I multiplying what? The square root of pi. And we'll remember that this will always be equal to this. So I won't be repeating this. And this is going to give me, if I multiply this, remember, according to the law of indices, if I have x, the square root of x, this is going to give me x to the power of 1 divided by 2. So that means this expression is going to give me the exponent of pi I multiplied by pi to the power of 1 divided by 2. Now, if you notice, you're going to find out that this is already carrying 1, right? So I can simply simplify this. Go ahead, please. I can simply simplify this. If I simplify this, what is this going to give me? This is carrying the power of 1, and this is carrying the power of 1 divided by 2. Then I'll have that expression to give me the exponent value of pi, which is 1, multiplying the exponent value of multiplying 1 divided by 2, and all of these will be to the power of I. Now, this is useful when it comes to the law of indices. So I can simplify this expression. Considering the laws of logarithm, if I have an expression like this, I can expand this to give me, if I have a to the power of x multiplied by y, this can simply be expanded to give me a to the power of x multiplied by a to the power of y, right? And if I simplify this according to the law of indices, I have, according to the multiplication law of indices, I'll have x plus y, the power of x plus y. So that means this can be simplifiable. Now if I simplify this, I will have this to be simply the exponent value of pi to the power of 1 plus 1 divided by 2. And that's that. Now if I simplify that, I'm going to have this to give us the exponent value of pi to the power of 3 divided by 2. Now remember, I still have my I, and all these will be to the power of I. Great. Now if I simplify this, what am I going to have? I'll have this whole expression, the exponent will have to multiply, and I'll have this whole expression to be equal to the powers will have to multiply, and that will be what? Pi to the power of 3 divided by 2 multiplied by I. and this is exactly the expression we are going to have. So from this expression now, I can now equate this expression to this, because whatever value I get for this is going to still give me this. So I'll have the expression exponent of pi to the power of 3 divided by 2 multiplied by I to still be equal to my negative 1 to the power of pi. So this is equal to this. Now, using Euler formula, I've been able to identify that and reduce this to this. So how do I simplify this? I'll still remember a Euler identity. And what is that Euler identity? That if I have the exponent of theta pi, the exponent of theta pi can be equal to the cos of theta plus the I of the sine, I multiplied by the sine of theta. These are a Euler identity. Now, with this representing this and I representing I can find the value of the exponent value of pi, 3 divided by 2, I. And that will simply give me my cos of pi to the power of 3 divided by 2 plus I multiplied by sine of pi to the power of 3 divided by 2. So that simply tells me that the value of negative 1 to the power of the square root of pi, which is still this, can simply be equal to the cos of pi to the power of 3 divided by 2, right? Plus I multiplied by the sine of pi to the power of 3 divided by 2. And that is the solution we are actually looking for. So you see, such expression can be broken down to give us this solution. And this is the solution we are actually looking for in this Olympiad Maths question. I took out my time to show you this, and I know this will be a valuable solution that you can make good use of. If you have any comment on this solution, or you want to say anything as regards this, just pick me up on the comment section. I will be able to interact. But thank you all who have been part of this, who viewed this solution and worked along with me as I solved this, and I do appreciate your viewership. Some other times we'll see as we solve more other questions like this. Thanks so much for watching.